Let's quickly recap the key points in this section. Multi-threaded applications can do more in less time, but they're challenging to build. One of the problems in multi-threaded applications is a race condition, which happens when multiple threads try to modify an object concurrently. We may get wrong results, or our application may crash. Another problem in multi-threaded applications is that a thread can change an object, but the change may not be visible to other threads due to caching. We talked about various strategies to prevent these problems. The first strategy was confinement, which means not sharing data across threads. We also talked about synchronization, which involves locking and makes your code run sequentially. So try to avoid it if you can. We also talked about atomic types. These types don't use locks. Instead, they use the compare and swap technique. They're great for implementing counters. We also talked about partitioning. Concurrent collections in Java use this technique to allow multiple threads access different segments or partitions concurrently. So that brings us to the end of this section. In the next section, we're going to talk about the newer, higher level constructs for building concurrent applications in Java. So I will see you next.